Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Good evening. Hi all teachers, parents and wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with EDD Malaysia and Kelab Guru Malaysia with the hashtag of bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of the Kitab, Al-Fatihah for the Muslim, and a moment of silence for the non-Muslim. Al-Fatihah. So how's everyone today? My prayer that everyone is in the best health and ready to proceed with today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Nur. You can call me Madam Nun, and I am your moderator for today's class. I am also a lecturer at College Matrikulasi Negeri Sembilan, Kuala Pilah. Together with us today is Teacher Hafsah AYU, our host controller from SMK Sultan Sulaiman, Kuala Terengganu, and our observer is Teacher Suryati from SMK Sri Serdang, Selangor. All of us here are to ensure that today's session running smoothly. And the most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is a very experienced teacher from SMJK Yuhua, Kajang, Selangor. So let us give a warm welcome to our presenter. For the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel. And all of you can also visit channel Teacher Suryati, Teacher Hafsah AYU, and my channel to get a lot of physics learning material, and not forgetting to subscribe their channel too. So as usual, the lesson will last approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. Remember that you can only use EDD email to claim the certificate. For credit claim, you need to collect the 1-letter and 4-digit codes, which we'll announce separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind students to use appropriate language and use appropriate profile picture if possible. Okay, if you wish to post comment in the chat box. I am pretty sure all of you here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answers. Before I give Madam Rosmaya to present, I will announce the first digit code for the credit claim. So make sure that you write down somewhere, yeah. So the first digit code is A5. Okay, A5. So without further ado, please welcome Madam Rosmaya to start her presentation. Okay.
Okay. Hi everyone. Okay, welcome to physics class. Okay, free tuition online class, Academy YouTuber. And thank you to our moderator, Teacher Nun. Okay, so before we start, okay, I would like to introduce the teams for PRIU, the PRIU teams in Academy YouTuber. Okay, so we have all together here 5, okay, PRIU teams. The first is from, for today, our physics PRIU Academy YouTuber team. Okay, I'm the leader, I'm Madam Rosmaya, and also we have here all physics teacher here is Teacher Su. Okay, then Teacher Anon, and also Teacher Ayu. Okay, and not here with us is Teacher Suhaya. Okay. So the other team, we have maths team led by Teacher Im, and also we have biology team led by Cikgu Faiza, and chemistry team led by Cikgu Shahnon, and perakaunan and economy led by Madam Fizi, And the other subject teams is from STPM subjects, pengajian AM, MURID, pengajian perniagaan, and also perakaunan STPM. Okay, so what are we going to discuss today is solving problems on projectile. So you all will be able to solve projectile problems by applying appropriate problem solving techniques. Okay, so tools for solving projectile problems. Okay, what tools are needed? Okay, what tools are needed? Okay, we need linear equations. Just memorize these three, enough already actually. Okay, this one you've learned in form 4, form 5. Okay, from V equals to U plus AT, then V squared equals to U squared plus 2AS, and S equals to UT plus half AT squared. Okay, so V you know already, right? Is a final velocity, U is initial velocity, A is acceleration, A is acceleration, and T is time taken, and S is the displacement. Okay, so for projectile problems, we need to separate by using the two different components, okay, horizontal component and vertical component. Okay, then you must be careful with the sign for the A and all the V, U, A, and T you use lah, especially for the G and S, okay, for the acceleration due to gravity and the displacement. Okay, whether it is a positive or negative depends on the Cartesian plane you choose, okay, the fixed point you choose. If the projectile is like this, okay, and the Cartesian plane you choose is this one, horizontal and vertical component, or like this, depends on the projectile situation given, or like this, and the fourth is like this, okay. So for the first one, the G will be negative, okay, because the direction of the motion of the object is upward, okay, upward. So the G acceleration due to gravity for the vertical component is negative. Okay, this one, the G will be positive because the motion of the object is downward. And for this situation, the G is also negative because the motion, initial motion always refer from the fixed point you choose. If this is the fixed point you choose, so the motion of the object is upward, right? So the G you use will be negative to use this linear equation. So the G will be negative. And lastly, also negative. Okay, refer to the motion of the object. Okay, and then for the S, for the first type of projectile here, it's positive. The S is positive. Okay, refer to the fixed point you choose here, the origin of the Cartesian plane you choose here. Okay, so S is a positive. For the second projectile, positive also S. For the third one, can be positive, can be negative. Depends on the position, point you choose. Okay, if you choose one point here, S will be negative. If you choose the point on the above the Cartesian plane here, on the above x-axis, so the S will be positive. And lastly, this one S positive lah, because the projectile path there is above the fixed point here, okay, above the x-axis. Okay, so now for the horizontal component and vertical component, okay, remember that you always resolve the component. Let's say at the beginning initial state. So the U is always tangent to the projectile path. This is the projectile path. So the U always tangent to the curve. Okay, let's say the angle made is theta. So you resolve the component U cos theta and U sin theta. Okay, for horizontal component and vertical component. So at each point on the projectile path, also you do the same. Let's say this is the V, second V, second velocity, we name as V1. So the tangent to the curve is the direction of the V. Okay, the component will be, let's say V1, we call this as V1x and V1y. So the V1x will be equals to the initial. Always the horizontal component of the V speed or velocity is always the same. as the initial. Okay, so if here is u cos theta, here also u cos theta. The changes is only in v. So at the peak, the v, let's say this is second velocity, we choose on the point on the projectile path. So at the peak, the v will be v component x will be u cos theta. Okay, you see it's always the same, u cos theta, the horizontal component. And at the peak, the vertical component will be 0. Okay, remember this. Must bear in your mind all this. And then again, when going down, so let's say we choose this point. So V3 is the velocity direction of the velocity tangent to the curve, the projectile path. And the horizontal component, again, you see u cos theta, you see or not? It's the same horizontal component, but the vertical component will change, becomes V3. Let's name this as V3y. Okay, now it going, the direction is downward. And lastly, to this point, the component will be the u cos theta. Okay, it's the same for horizontal component, but the vertical component will be the same as back to the initial. Okay, because the projectile path here form a symmetrical curve actually. If you cut this into half in the middle at the peak here, so actually the curve is symmetrical. Okay, left and right side. So here also will be same u sin here the b, but the direction only is different, downward. The u sin theta here, will be negative. The angle will be back same to the initial. Okay, so now we start the first question. Okay, I give in the description below, okay, in this video, in our live. So I've given already the question to be solved for today. Okay, doing together. I hope you all done the question so that we can discuss together. Okay, so let's read together the first question. A particle is projected from the surface of the earth with a speed of 20 meters per second at an angle 30 degrees with the horizontal. Okay, so determine the time of flight and then the range and maximum height. Okay, so we solve for A first. Okay, so what is given? What is given in the question? You are given 20 meters per second, so this is the initial speed. And then you are also given angle theta. Okay, we are going to determine the time. Okay, so we draw a Cartesian plane here. Choose a fixed point, and fixed point surely at the beginning lah, at this point. Okay, the initial here. And from these three equation of linear motion, so which one to be choose depends on what is given. Sometimes more than one can be used. Okay, so we have u, we have t here. So the best is we use the third linear equation, because if we choose the first one, we don't know two variables. We don't know v and we don't know t. T is what we're going to find, right? So we don't know v, we don't know t, we don't know two unknown. We have two unknown. So choose the best equation so that you can get the what you are going to determine now is time, right? So become only left one unknown. Okay, so we choose the vertical component for just now, s equals to ut plus half at squared. Okay, and then the vertical component for the g will be negative because the direction of the object is upward. Okay, direction of upward, so it's negative direction from the acceleration due to gravity. So that's why the g is negative. So this is where the student always make mistake. Okay, so be careful. Negative g. Okay, so that's mean negative 9.81. Okay, now we substitute the value. Okay, time of flight means from here then back to the ground. Okay, from here back to the ground. So that's mean the displacement is 0. Okay, so this is the Cartesian plane. You draw two component. Later we are going to resolve the component. Okay, vertically and horizontally. Okay, then the sy back to ground here will be 0 because time of flight. So back to the ground. So sy will be 0 and refer to the fixed point here. Okay, that's why 0. Then the U, is of the component of 20 meter per second here. Initial velocity is tangent to the curve, the projectile path. So the component will be 20 cos 30 degrees and the vertical component will be 20 sin 30 degrees. Okay, horizontal component and vertical component. Okay, so now this is horizontal vertical component. Why? So therefore we choose 20 sin 30 degrees. Okay, then 9.81. So you see from the equation here, we have only one unknown to be calculated. The question asks for time, right? So we have t, only unknown. They're the only unknown here. So we can solve for t. Okay, so we simplify. So we get this. And then we can use factorization or it's up to you to use the factorization method or the formula in maths you've learned. Okay, you can use negative b plus minus square root of b squared minus 4ac per 2a to get the time taken. Okay. Okay, so did you all, I forgot to ask you all just now, okay, whether you, what are your answer, okay, but you can write there in the chat box there if you've done the question. Okay, so you can write there the answer for A, B, and C, if you done it. Then we can check together here whether you get the correct answer or not. Okay, so this is time taken for the particle to travel from here until back to the ground. Okay, 2 seconds. It takes 2 seconds. Okay, then we can use another method too actually. Use factorization also we get the same answer, 2 seconds. Like this one. Okay. But you will get 2 answers. So the T0 will be at initial. That's why 2 answer, because this is T squared. So the T0 is at the initial and another one 2 seconds will be at back to the ground, when it reach to the ground. So that's why I got 2 answer. So this is quadratic equation, S equals to ut plus half at squared. So this equation is a quadratic equation. That's why you got 2 answer for t. But the question asks time of flight, so we choose 2 seconds. Okay. Okay, next we are going to determine the range. Okay, so what answer you all get, you can write there in the chat box so that we can check together whether it's correct or not. Okay, don't be afraid to make mistake. You can write there. Okay, next for the range. So what is meant of range? Range is distance, horizontal distance, okay, from initial and then back to the ground when the object reach the ground here. Okay, from the 3 linear equation, we have what was sutat. I love to memorize like this, what was sutat, instead of saying v equals to u plus at, v squared equals to u squared plus 2as, and s equals to ut plus half at squared. It's faster to say what was sutat. And then you all actually get used already, right, with this equation from form 4, form 5. Okay, so now the suitable to be chosen is also the third equation, okay, sutat. Again, why? Because we don't know 2 variables. If you use if you choose the other 2, you don't know v and we don't know v and t. T also can just now actually, but the best is this one lah, s equals to ut plus half at squared. Okay, so we choose horizontal component because horizontal component automatically g will be 0. Okay, for horizontal component, g automatically will be 0. So that's why the equations become easier because it's only involve s equals to ut. Okay, s equals to ut. So the component will be ux will be 20 cos 30 degrees horizontal component. Initial horizontal component, u, okay, u is initial horizontal component. So 20 cos 30 degrees. And then time taken just now, calculated already in A. So it's 2. So you substitute 2 into the equation here. And the x-axis, s-axis, this horizontal displacement, this is what we are going to determine, kr. So r equals to 20 cos 30 degrees times 2. Okay, then we can solve r, we get 35 meter. Okay. Okay, so if you have any problems, you can just write there in the chat box. Okay, you can just write there in the chat box. So lastly is the maximum height. So what is the maximum height? That's mean in the middle here. Okay, let's represent it with letter H, capital letter H. So this is what we are going to determine, maximum height. Okay, again from these three linear equations, which one to be chose? Okay, we are going to determine H. So that's mean we can use the second one. Okay, the second one. Okay, so we can choose. Why we can choose here the second one? Because at the peak here, it is understood that the V is 0. So that's why we can choose the second equation. Okay, so we know V, we know U, so the only one left is S. Okay, A at the peak will be 0 if you choose horizontal component, but we are going to choose the vertical component here. Okay, because the V will be 0. Easy to substitute into the equation here. So from VAS just now, we choose vertical component. Okay, why we choose vertical component? Because the V will be 0 at the peak. Okay, automatically in your mind, you must remember this. At the peak, always component V is 0. Okay, so Uy will be 20 sine 30 degrees here, the vertical component. 20 sine 30 degrees. Initial, U is initial. Initial vertical component, 20 sine 30 degrees squared plus 2A. So A is negative G. Why negative? Because the direction of the motion of the object is upward. So that's why the A is negative G. And lastly is what we are going to determine is H, the maximum height. So you see now we have all the values except for H, which we are going to determine if we use this equation. So we get H. This is the peak. Just now I didn't put. So vertical component at the peak Vy is 0. Vx will be 20 cos 30 degrees. Okay, so we solve for H. So the H is 5 meter. Okay, 5 meter.
Okay, Madam Rosmaya, can we announce the second digit?
Okay, can.
All right. So, hi students. The second digit code for the credit claim is 4. Okay, number 4. The second digit.
Number 4.
Okay, thank you. You can continue, Madam Rosmaya.
Okay, so we continue with next question. Actually, we can use more than one method, like just now for maximum height. Instead of using V squared equals to U squared plus 2AS, actually you can use S equals to UT plus half AT squared. Okay, like I said just now, sometimes can use more than one equation here. Okay, so if you choose the third one, this one must be careful with the time. Okay, with the time use. Okay, if you choose this one and you choose a vertical component, okay, so the time you cannot choose 2 seconds like we get A here. A here we get time 2 seconds because from here and back to the ground. Okay, the time of flight. But in this case, we are going to determine maximum height. So the path here, the trajectory of the projectile is symmetrical left, right. Okay, so during class we prove already why is a symmetrical. Okay, proven already. So the time taken also become half. If 2 seconds from here to here, so that's mean time taken to reach the peak here is 1. Okay, you get same answer. So the U is the same. You write 20 sine 30 degrees, the initial velocity, vertical component. The G is negative 9.81. And you get the same answer, which is 5 meter. Okay. So it doesn't matter actually, as long as if you choose the one of the equation you choose and leaving you only one unknown to be determined. Okay, next we go to question 2. Okay, question 2. So a rock is thrown horizontally off a 100-meter cliff. So it lands 95 meter away, and what speed was it thrown? Okay, finds its speed when it lands. So 2 questions here. Okay, the first one is what speed was it thrown? And then find its speed when it lands. So that's mean initial speed and final speed. Okay, so you can imagine this by drawing. This is the vertical displacement, okay, 100 meter, and this is horizontal displacement. And we are going to find Ux, okay, and you are going to find the speed when it lands. Okay, so you can imagine like this. The graph we use is this one. Okay, because it's thrown horizontally. Okay, the keyword here, thrown horizontally. So the graph is like this. So this is the fixed point you choose, 100 meter from the origin here. So the component later we resolve into these two, components. Okay, so Ux, because it is thrown horizontally, so initial velocity only consists of one component, horizontal component only. We have no vertical component. That means Uy 0. Okay, from the word here, horizontal. So we only have Ux. So this is what we are going to determine, Ux. Okay, so from these 3 linear equations, so which one to be choose? You are given only 100 meter and 95 meter. So if you are going to choose 100 meter here, so that means you choose vertical component. Okay, vertical component. So to find Ux, you can choose the third one. Okay, so for the third one, S equals to UT plus half AT squared, we choose vertical component. So S will be 100. Okay, S will be 100 because the fixed point we choose here. This is the origin of the Cartesian plane you draw. So that means Sy is 100, positive. Okay, then the U will be 0 because the object is thrown horizontally. So the U initial velocity component Y will be 0 and plus half 9.81. So 9.81 G value is positive. Okay, why positive? Because the motion is downward. Okay, the motion is downward. So G is positive. Okay, be careful. This time the G is positive and T squared. So you see the equation here only consists of T value which is the unknown. So you can determine the T value. So we get the T value and okay, this is positive. So 4.52 seconds. So that we can calculate the speed later. Okay, so for the speed we use horizontal component. This 95 meter is the horizontal component. So same thing, same equation, we use S equals to UT plus half AT squared. Okay, so S will be 95 meter here. Okay, 95 meter, but the G is 0. Always memorize this. For horizontal component, the G is 0. Okay, for horizontal component, the G is 0. Okay, so leaving the equation only S equals to UT. Okay, displacement equals to velocity times time. Okay, so displacement is 95, horizontal component. Ux is what we are going to determine. And time taken just now, 4.52 seconds to reach here. From here to reach the ground. And plus 0, so you get the speed Ux equals to 21 meter per second. Okay, so you round it off to 21 meter per second. Okay, so did you get the answer? Ux equals to 21 meter per second. Okay, hopefully you get, because I've given these questions earlier already. Okay, if got any problem, you can ask there right in the chat box. And I can see there Teacher Im there. Okay, thank you. Welcome Teacher Im to join a physics class today. Okay. Then we continue with the next question here. Find its speed when it lands. Okay, the speed when it lands. Okay, so at this point, at the ground here, the speed is tangent to the curve. So the question asks for speed when it lands. So that means the tangent to the curve is this way. So you need to find the vertical component and horizontal component. Okay, vertical component is all the same at all points on the projectile curve. So that means the horizontal component is the same as the initial 21 meter per second. So no problem with the horizontal component. But the vertical component, Vy, we need to use which equation to be chosen to find Vy. Then we can use Pythagoras Theorem to solve for V. Okay, so okay, Akira, you can write there if you got the answer. Okay, so that we can share together. Whatever answer you get, we can share here. And if you got the correct answer, later I can give you a clap. Okay, so now we choose the simplest one is V equals to U plus AT. Because T you know already, right? So you can choose the first equation to find this Vy. Okay, so component Vy equals to Uy plus GT. GT is the same. So Vy equals to the initial Uy will be 0. Okay, because I repeat again, the rock is projected horizontally. So the Uy will be 0. G is positive, okay, because moving downward. And T is 4.52. So you get Vy equals to 44.3 meter per second. Or you can use Sutat also actually to get the Vy. Okay. Or you can use VUAS, VUAS, because the Sutat don't have V, right? So we choose second one, VUAS. So for VUAS, you choose a vertical component. So the U also 0, Uy, vertical component at initial 0. 2, G is 9.81, but the S is 100. Okay, the S is 100. So you get a Vy 44.3 also same. So it's up to you which one to be choose. Okay. Because at this point, okay, the S displacement is 100 from the top. So it's positive. S is positive here. Okay, the fixed point is here. This X axis. So that's why S is positive. So no matter which one you choose, you still get Vy 44.3. Okay, done. After you get Vy, okay, so you can use Pythagoras Theorem to calculate V. So you substitute this Vx and Vy. Vx is 21 and Vy is 44.3. Remember I said the V horizontal component always the same at all points. So that's why Vx is equals to Ux 21 meter per second. And you get V equals to 49 meter per second. Okay. So for the okay, that done. For the direction, don't forget the direction, because V is velocity. Okay, so you can you must always write together with the direction shown by the angle theta. Okay, this angle theta. If not, you won't get full marks. So theta must be written together to show the direction of this V. Okay, so you can use trigonometric ratio, which is tangent theta equals to Vx per Vy. And substitute the Vy 44.3, Vx 21. So you get 64 degrees. Okay.
Okay, Madam Rosmaya. Really great explanation. So, would you like to take a break for the advertisement? So let's watch the advertisement, everyone. Thank you.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, so Madam Rosmaya, I will announce the third code so that after this we can continue discuss the solution, right? Okay, so hi students, our third code for today's class is number 7. Okay, number 7. Okay, thank you. Madam Rosmaya, you can continue.
Okay. So now continue with question 3. If you got the answer, you can write there in the chat box, the answer for question 3. Okay, we read the question first. A basketball player is standing on the floor 10 meters from the basket. And the height of the basket is 3.05 meter. And he shoots the ball at 40 degrees angle with the horizontal from a height of 2 meter. So what is the acceleration of the basketball at the highest point in its trajectory? And what speed must the player throw the basketball so that the ball goes through the hoop without striking the backboard? Okay, so you can imagine like this. Okay, throw the basketball is 10 meter from the basket. So the height of the player is 2 meter and the height of the basket is 3.05 meter. So this is the projectile taken. Okay. So for the A, acceleration of the basketball at the highest point in its trajectory is 9.81 meter per second and direction is downward because the horizontal at the highest point here. Okay, we only have one component of V, which is to the which is horizontal only. So vertical we don't have. Vertical is 0. Okay, horizontal component of the V is 0. So that's why we still have A, acceleration due to gravity, only one component, which is 9.81 meter per second downward. So that's why the answer is this. Okay, now we go to B. At what speed must the player throw the basketball? Okay, that means the initial speed. Okay, the initial speed is tangent to the projectile curve. So we need to find the two component. Okay, so this is the U we are going to determine. So the component will be U cos 40 degrees and U sin 40 degrees. So you need to determine this U. Okay, now from the linear equation, we need to choose the component and the fixed point is here at this point, and the highest and the what you call it, the ball, the basketball reach here at the height 1.05 meter. Okay, 1.05 meter because 3.05 minus 2. Okay, 1.05 meter. So from these three linear equation, which one is the suitable to be choose? So we choose the third one. Okay, the third equation, S equals to UT plus half AT squared. So we need to involve two equations here actually. Okay, to choose the just now we cannot because we don't know this V. We don't know, T also we don't know. Okay, now for horizontal component 10 meter first, we use this one 10 meter first. Okay, so for horizontal component, automatically G is 0. Okay, G is 0. So Sx equals to Uxt. So substitute the U horizontal component, initial horizontal component velocity, U cos 40 degrees, T. Okay, find T first because we are going to find speed. So find T first. And the horizontal distance is 10 meter. Okay? And this 10 meter is positive. Okay, because the fixed point is here and is to the right. So it's positive. So you get T equals to 10 per U cos 40 degrees. So this T we keep for a while at here because we are going to choose the vertical component. We are going to use this 1.05. Okay, so keep T here. Next, we use the horizontal vertical component, same as equals to UT plus half AT squared, but we choose the horizontal vertical component. Okay, horizontal vertical component. Okay, because 1.05 is vertical. So you substitute this 1.05 into here, and for vertical component, the G is negative. Why negative? Because the basketball is thrown upward. Okay, that's why the G is negative. Okay, so you substitute the G negative 9.81, SY is 1.05, and SY is positive because it thrown from here. So the fixed point is here, so upward, throwing upward, same as the motion. So therefore, the S measured from here is positive, value 1.05. Okay, so this T you can substitute into these two, UT, and another one is T squared. So you substitute into here. Okay, can cancel out the U. Okay, cancel out the U. And in this equation, we have only one unknown, which is U, which we are going to calculate. The question asks for speed, right? So the equation here only leave unknown U to be calculated. Okay, so you solve for U. Okay, solve for U, and you get U 10.7 meter per second. Okay, any problem or not? If got problem, you can ask there in the chat box. Got problem? Okay, looks like no one mentioned there. Madam Nun, no one there? Okay, so if it's okay, then we can go to question 4. We can go to question 4. Okay, done for question 3. Okay, question 4, we read first the question. A cannonball is fired with an initial speed of 180 meter per second from a 150 meter high cliffs at an angle of 30 degrees from horizontal. Okay, very good, Meronisa Shabir. Okay, so angle is 30 degrees from horizontal. Then determine the distance D at which the cannonball strikes the ground, and then B, the maximum height H above the ground achieved by the cannonball. Okay, sometimes diagram not given. So if you draw your own diagram, sometimes it might help you. Okay, so this is the cannonball. Okay, shoot at the 150 meter height. Okay, then it land here. So the plane, the Cartesian plane we choose is this one, because this is the initial speed starting to launch. The cannonball is launched here. So usually where it is launched, we draw the origin of the Cartesian plane at that point. Okay, then D is what we are going to find, distance D, which cannonball strikes the ground. Okay, this is the distance we are going to find. And the speed is 180 meter per second. So tangent to the curve here, projectile curve. So 30 degrees, so therefore the component will be 180 cos 30 degrees and 180 sin 30 degrees. Okay, so the distance here, because this is horizontal, so you can draw the horizontal, you can choose the horizontal component. Okay, so which one to be choose? Because you are given 150 and this one is D, so you can choose again the third one. So usually the third equation here always for time, to determine time. Okay, so we can use the third equation and horizontal component, which T, one of the T here can be cancelled because the G horizontally is automatic 0. Okay, automatic 0. So leaving the equation simpler, becomes xx equals to uxt. So xx is D, which we are going to determine. Okay, D. and the U is 180 cos 30 degrees, horizontal component, horizontal component, and T, we find T first. Usually S equals to UT plus half AT squared, usually always used to be, to find T, okay, to find T. Okay, so now we have two variable we don't know, D and T, okay, D and T. So T is the problem. Okay, so we use again S equals to UT plus half AT squared, but this time vertical component to find this T. Okay, to find this T. The target is to find D, but we don't know two variable here. Got two unknown here. So that's why we find T, but this time we choose a vertical component. So S equals to UT plus half AT squared. So you substitute SY as negative. Why negative? Because the fixed point is here. So 150 is under the, means below the x-axis. Okay, below the fixed point you choose here. This is the fixed point where the cannonball is launched. Yeah? So therefore 150 is under that point, below that point. So that's why negative. This is where the student always make mistake. So be careful, all students. So the SY is negative 150. Okay, so you can write there somewhere in your notes, in your reference, your book or whatever. Okay, take note this one. Okay, then the UY is 180 sine 30 degrees. Okay, this is vertical component, initial vertical component of velocity. And T is what we are going to find. And plus half negative 9.81 T squared. The G is negative. Why the G is negative? Because direction of the projectile is upward. Okay, upward against the gravity, acceleration due to gravity direction, which is downward. So that's why it's negative. Okay, so now you solve for T. Okay, so solve for T. Remember this shape. This shape, the G is negative, S is negative. Okay, so now you solve for T. And because the equation is like this, so you need to use the maths formula for quadratic equation. So the T equals to, the formula is negative B plus minus square root of B squared plus 4AC per 2A. Okay, for the 2A. Okay. So you solve, you get T equals to 19.9. 19.9 second. Okay, so we substitute into here. So we get D 3,100 meter. Okay, 3,100 meter. Okay, so next question B. The maximum height H above the ground achieved by the cannon. Okay, so the height D equals to 3,100 meter. Okay, wait, student, because my battery, okay, teacher Non, my battery is going to so I need to connect to the power supply.
Alright. Okay, have your time.
Okay.
Okay, student, if you have any question, you can write down on the in the chat box. Okay, maybe we can help you. Or if you want to try to calculate the maximum height first, you can calculate and then write down the answers. Or if you have done the solution, if you have tried earlier, you can write down the solution on the chat box. Okay, so Madam Rosmaya, you can continue.
Okay, okay. Sorry, because the connection is loose. That's why I need to. Okay, I'm okay already, so we can continue. Okay, now question B. Back to question B. We are going to determine the height H above the ground. Okay, the height H above the ground, which must be measured from here. Okay, this H. So achieved by the cannonball. Okay, from this three linear equation, for the height above the ground, usually we choose VUAS, V squared equals to U squared plus 2A S. Because we got S here. S here is H, okay, and the U is initial velocity, and the V we can use at the peak here will be 0. Okay, will be 0 because at the peak. Okay, vertical component, the V will be 0 here at the peak. So you substitute 0 here. U is the initial component, vertical 180 sine 30 degrees squared plus 2. Again, G is negative because upward direction, and we can find H. But this H, okay, this H is the H prime measured from here. Okay, H prime measured from here because the fixed point is here. Always refer to the fixed point. So the H here, the S here is from the fixed point. Okay, refer to the fixed point. So this is the height we are going to determine first. So you get H, okay, solve this one, you get H 410 meter. 410. Okay, Chun Wei got 232 meter. So be careful. So the H here, be careful the H here. So H prime is 410 meter measured from here. So all together means from below here plus 150. So the 410 plus the 150. So therefore the answer is 560 meter. Okay, Chun Wei? Okay, so what about the rest of you? Do you get the same answer? So be careful, the question asks maximum height above the ground. So that's mean measured from here. So but if you use the VUAS, the H you get or the distance you get is from the fixed point. Okay, from a fixed point. So therefore you must plus the 410 with the 150 meter. Okay, so done for question 4B. If you got any other if you want to ask anything, you can write there in the chat box. I hope you all found understand why it is 560 meter. Okay, the question asked to measure above the ground. Okay, so we go to the next question. Oh, actually you can use the third equation also. Okay, S equals to UT plus half AT squared. So like I said just now, sometimes more than one equation can be used. So if you use Sutat, you can find the time taken here. Okay, so the time taken here you can use what? Okay, V equals to U plus AT. You choose the vertical component. So the Vy will be 0. Okay, because at the peak, right? At the peak, so Uy will be initial vertical component, velocity 180 sine 30 degrees. Not squared, don't have squared here, typing error. Then the G is negative 9.81 T. So you get the T here, you can substitute into here. Okay, so you get same answer 410. Okay, same answer like just now, 410. This height. So it's up to you to use VUAS or Sutat. But the time taken you need to calculate using the what? Using what? Okay, so you get 560 seconds. Okay, so you cannot use time taken 19.9. This is time 19.9 until here. So you need to calculate the T again if you want to use Sutat. So must be very, very careful. Always refer to the fixed point you choose here or where it is launched, where the object is launched for projectile path. So must be very careful. Okay, next. If no question there, we can go to the next question. Okay, this is quite famous question also. Okay, object is launched here 20 meter per second at 30 degrees angle, okay, from the horizontal, and there's a wall here 3 meter. Okay, so we are going to find out whether the object hits the wall or not. Okay, quite famous question also. They can adjust the type of question they want to ask you, but basically all the same method from what was Sutat. Okay, very easy actually, projectile equation. Okay, what was Sutat? Just choose which one. Okay, now from this, this is 10 meter given, 3 meter given. So you choose horizontal component first, then vertical component. We have 3 meter vertical component from vertical component, 10 meter from horizontal component. Okay, so we choose Sutat. Okay, so we choose vertical component first. Use this 3 meter to find the time taken. Okay, to find the time taken. So the S equals to ut plus half 0t squared. Find the time taken first. So substitute the horizontal component 10 meter to find the time taken. 10 equals to u is 20 cos 30 degrees horizontal component. Okay. 20 cos 30 degrees, then time we get 0.577 second. Okay, so you substitute into here. Time is a scalar, so it doesn't matter you choose vertical or horizontal component, it will be the same. So you substitute here, then you get SY. Okay, vertical, the horizontal, the vertical distance, okay, at reaching at here. So you get 4.1 meter. Okay, 4.1 meter larger than 3. So 4.1 meter larger than 3. So that means the object doesn't hit the wall. Okay, the object does not hit the wall because larger than 3 meter. It managed to launch above the wall. Okay, not? So if no question there, I can see no question. So we can continue with the next question. If I explaining too fast, you can write there also in the chat box there. Okay, so next question. Okay, sometimes the question just said direct to find speed, the speed of the object right before it hits the ground. Okay, so that means the speed at this point at the ground here is tangent to the curve, the projectile curve. So you need to find the component of horizontal component of velocity and vertical component of velocity. Okay, so at this point, V is what you're going to find tangent to the curve, and we need to determine the Vx and Vy, vertical component and horizontal component of the speed or velocity. Okay, as I see just now, the horizontal component is always the same. Whatever point you choose along the path, so it will be equals to the initial here. So Vx no problem, it's u cos theta. Okay, so the u is 11.4 and the theta is 52.1. So substitute, you get Vx. Okay, then for the Vy component, okay, you can choose from here what was suited. So choose the easiest one. You are given 18 meter, right? So you choose the vertical component from Vuas, from Vuas. Okay. Okay, so the S will be 18. Okay, so from Vuas, choose the vertical component. V squared equals to U squared plus 2AC. Remember that the object is launched upward, so the G is negative. Okay, then you substitute. The Uy is 11.4, sine 52.1. Okay, then the Sy vertical component is 18 and it is negative. Okay, it is negative. Be careful. This is negative Sy. Why? Why negative? Because the fixed point is here where it is launched. It is launched here, so this is the fixed point. So the 18 meter is below that point. Okay, below that point. So I didn't draw the Cartesian plane here. So this is the fixed point. So it's below, that means the Sy here must substitute as negative. So this is where the student always make mistake. The positive and negative sign. So this is negative. Okay, so you solve for Vy. Okay, so Vy is 20.8 meter per second. Okay, 20.8 meter per second. So you write your own notes there for this one, because this is the common mistake every year student make. Okay, now it's time to solve using Pythagoras Theorem. Okay, so V square root of V squared plus Vx squared, Vy squared plus Vx squared. So substitute these two both into the equation here. You get V 21.9 meter per second. So this is the speed. Okay, if the question asks the speed, so that means the speed tangent to the curve. So that's why you need to find the component, horizontal component and vertical component first. Then you solve for Pythagoras using Pythagoras Theorem. But your answer is not finished yet because you need to find direction. Direction shown by the angle. So this angle can use trigonometric ratio, Sauchatua. So you use tangent. Okay, tangent equals to opposite per adjacent, 20.8 per 7. So you get angle 71.4 degrees. Okay. Okay, so that's all for question 6. And lastly, I'm going to jump to question 8 because it's 6 o'clock already. So I'm going to jump to question 8. Okay. So a golf ball is projected from A with an initial velocity of 40 meter per second at an angle 55 degrees from the inclined plane. So neglecting air resistance, determine the maximum height reached by the ball and then the time taken by the balls to strike point B and the distance between point A and point B. Okay, so maximum height. To find maximum height, so we resolve, as usual, we resolve the component here first. This is the fixed point. So the component will be 40 cos 35, 40 sin 35. Why 35? Because the angle here 55 is from the inclined plane. And the angle of the inclined plane here from horizontal is 20 degrees. So that means you use alternate angle here 20 degrees, here also 20 degrees. That means 55 minus 20 degrees is 35 degrees. So be careful with the angle you choose. Okay, now to find the maximum height. So this is the projectile curve. Okay, we chose. Okay, fixed point is here. So the H prime here is we can for H prime the maximum height usually we choose was so we choose was, so you substitute S here as H. Okay, then the G is negative because upward direction and the U is 40 sin 35 degrees. Vy at the peak here is 0, so you get H. You get H 27 meter. Okay, 27 meter measured from here. Okay, maximum height. So no need to measure from here, okay, because the maximum height reached by the ball, you can just mention it as 27 meter, okay, measured from the fixed point, okay, measured from the fixed point. Okay, now the time taken by the ball to strike point B. Okay, so from this what was sutat, so that means the time usually we use sutat. The time usually we use sutat. Okay, so vertical component, but we don't know this height. The height 27 is from here, not from the ground here. But the object, the golf ball here hit point B, so must be measured from the horizontal distance here, from point B along X here. So we substitute Sy as H. H is negative. We can use trigonometric ratio H for H. Okay. Then the U, we can choose the vertical component because all these vertical component. Then the time taken is what we are going to determine. So the H, we can use trigonometric ratio. So tangent 20 degrees equal to H per R. So therefore H is R tangent 20 degrees. So R is the horizontal distance here, R. So you substitute into here. Okay, so we still got problem with R, but don't forget, negative below the fixed point, so negative. So horizontal component R, no problem. We can use sutat horizontal component where the G is 0. So XX equals to UX times T. So UX is the 40 cos 35 degrees here times T. So now you substitute into here. So that means what left here is only variable T. The unknown here is only T. Then you can solve for T. So we leave this to write to be here because later we are going to solve C. So we are going to need this. Okay, solve for T first. Okay, so you become quadratic equation and use factorization. And you got T, 2 answers. Why? Because we have 2 points here. At this point and at this point. So at initial T will be 0. So reaching at B, the time taken to strike point B. So the answer is 7 seconds. So you must rewrite again. The answer is not 0. The answer is 7 seconds. because the question asks time taken by the ball to strike point B. Okay, and then lastly, question C. Okay, as we solve question B, actually we come up with these two, r tangent 20 degrees and 40 cos 35 degrees t here. Okay, so you can calculate AB using the Pythagoras Theorem, okay, which is square root of r tangent 20 degrees squared plus bracket this one r squared. So you just substitute what you've calculated just now, be the time taken into here. Okay, 7.1109 just now. Okay, so you get AB is 248 meter. Okay, not? So if you cannot get it, you can repeat watching this video to get the idea of what we discussed today. So hopefully I'm not discuss it too fast lah for today. Never mind, you have your teacher. You can ask your teacher later, your own teacher. So question 6 and 7 also, I will give the teachers here, or I can make a video from question 6 and 7 for you all to see. Okay, I give back this video to this session to Madam Non. Okay.
Okay, thank you so much, Madam Rosmaya. Very great explanation, right? So, Alhamdulillah, we have reached the end of today's session. So, congratulations to those who can follow us until from the beginning till the end. So, before we end our session today, I will announce the fourth or last digit code for credit claim. So, the digit is number 1. Okay, number 1. Okay, so all of you, please stop posting your comment for a while, and if you haven't clicked the subscribe button yet, please do so. Make sure it turn to gray, okay? And activate the icon bell so that you will not miss the next class session. Then if you find that the lesson was beneficial, click like and share to your friends, okay? Spread and share the goodness. Once complete, type down on the chat box before the certificate link is given. Actually, the certificate link is given right in the chat box. So, with the access code of #class AYU ED. Please take note, the link will end half an hour after this live. Make sure to use the ED email only to log in. Incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply the ED email is also given in the chat box. If you wish to get more information on the online classes, you can go to www.academyyoutuber.com. And to those who haven't joined ED Junior Telegram, please do so. So once again, I would like to thank all students for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. Feel free to share this free tuition class to your friends and teachers all over Malaysia. So I think that's all for now. See you in another session. Do forget the hashtag bermula percuma and selamanya percuma. Stay safe till we meet again next week. Same day and the same time. Thank you and Assalamualaikum everyone. Okay, bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.